So I started working on a small project with SQLite, and though that project is too big to really go over, I thought I can do a dummy tutorial of it. But before that, the first video is just going over SQL and some of the workflow things I have done. The Rust stuff will start in the second video. With that being said, let's get it. Okay, so in terms of SQL, I have a horrible memory. Just in general, I have a horrible memory. And because of this, I always reference documentation and reference notes and yada, yada, yada. So anytime I do SQL, one of the first things I reference is an old blog post written by me years ago on, I think, Blogspot. It's not maintained. It's just something I just look up for quick syntax. Anytime I want to know more, go like deeper in knowledge in terms of SQL and SQLite, then I do a Google search, file type PDF for a SQL book. And my favorite SQL book is The Definitive Guide to SQL. And then one of these links usually brings up a book. That being said, in terms of tools to use today, we are going to be using the DB browser for SQLite. So this is a tool that I'm not too familiar with, but anytime I'm like at a meetup or whatnot and people are new to SQL and definitely new to SQLite, this is a tool I point them to it just so they can see their database and be able to interact with it. So I figured it'd be a good opportunity to use it. Alrighty. Alright, opening the SQL browser. So one of the reasons I'm using SQL browser and some of the things I discovered is that via SQLite browser, one, I can use their interface to create tables. Two, I can sort of use it as a boilerplate testing playground to put things in the database, take things out, and make sure everything's written correctly. But three, and most importantly, I can take the SQL database and schemas and all that stuff created here and export it as SQL, save it to a file, and then read it in via Rust, and just to create my database there. So let's walk through that. And the database that we're going to be creating is a person, pets, persons table, pets table, and then a table to reference it to for pet owners. So pet owners is going to have its own ID, but it's going to have a reference to the person ID and the pet ID. So let's do that now. Part of the workflow I've been using is creating an in-memory database, just in case if something goes wrong, then I could just erase everything and start over again. Nothing gets saved to file. So let's start with the people. So you can use this interface. You can add fields, and adding fields, ID, and they have drop downs for things you pick. We already want it to be an integer. Primary key, auto increment, next field. And you can see down here that it writes out the SQL for you. So if you wanted to, you could just copy and paste that. Name. Our people have names. Yes. And that is going to be text, not null. And that's about it. Okay, so create the next table for pets. We're adding a field, ID, primary key, auto increment, add another one, name, text, not null, same as people. This is a very simple table. All right, so for the third table, which is going to be the pet owners table, for that one we need foreign key references, and I'm not exactly sure how to do that in that interface I just showed you. So I would typically just go to the SQL and just write it out explicitly. And I think I have that copy and pasted, so it's in my clipboard. So we can read through it real quick. It is drop table if exists, pet owners. Because if the table exists, I want to be able to drop it and then recreate it in case if I want to make some changes to it. And we have the create table if it does not exist, pet owners. We have the ID, integer, primary key, auto increment, standard. We have person ID, which is an integer and not null, so it has to be inserted. Same thing with the pet ID. I put a uniqueness constraint on it because I don't want duplicate entries of pet person matches. And then I put the foreign key references just to make sure that the IDs that I inserted into here exist in both the tables, the people's table and the pets table. And then for SQL, for running SQL, we have these two icons here. One is execute the current line and one is execute all. In this case, we can just execute all. And then we can come over here and see that we have our new table, which is pet owners. And here we can click modify table. We're not going to modify it, but we can look at it. It's all here. Cancel. All right. So one thing I did mention is that we have foreign keys. For SQLite, foreign key checks aren't necessarily always enabled. So you always have to double check. And in this editor, you check the here, the edit pragmas, and then you can see that the foreign key is checked. In order to verify that, let's put some data in just to make sure. Oh, in order to verify it, we should actually try to put something into that table. So let's do an insert, right? What is it? Insert into pet owners. We don't need an ID, we do need it's person ID, right? Person ID and pet ID. Pet. Values, and say 1 and 1. And since our database is currently empty, this should fail. So this one says execute current line, and we see here the error is because of the foreign key constraint. So let's put some data in it just to make sure it still works afterwards. So in the browse data, we can add new records to our tables. So new record, name, call you Marcus. New record, put a second person in here. Oh, it's writing over there. Willock. Apply. And then let's do the same thing to, not pet owners, pets. Create a new record. Give you a name. Yana. Apply. All right, so now that we have data in the two tables, the pets table and the people's table, this line should work. Execute current line. And now it says it was successful. So when we browse data, we go to pet owners and we see it here. So currently we have both written our schema for the most part and then tested out to make sure our database works, like basic workflow stuff. So now the interesting part is being able to export our database. And we can go to export SQLite file, and there are 4 files here, or 4 tables. We have people, which we wrote, pet owners, which we also wrote, pets, and then we have this last one, which is the SQLite sequence. From my understanding, anytime tables are created, that one's just created under the hood, maybe more like a maintenance thing. I'm not exactly sure of the specifics, but you don't necessarily need to export it. And then here we have options, keep column names, and insert into, multiple rows, yada, yada, yada. But most importantly, we have this drop down, which is export everything, export schema only, export data only. So right now, we have both our schema and we have some data. So I propose that we should export both just because we have one with data in it that we can test against by pulling data out before we even do anything else. And then we have another one that we can switch to that is just a schema and no data. And then we could just use that later on once we have our database set and we know what we're doing and our code is written. So that's typically what I've been doing. So export everything. Oh, and then this option, which is keep old schema or overwrite. I've been going with the overwrite just because. And then let's put this in a place. So I have a place in store. it is documents, GitHub, and SQLite example. And we just put it here. We can call this one all.sql because it's everything. Save. And then we can export it again. And this time we're changing it to just a schema. And we still want those three. We call this schemas.sql. Save. All right, so we've exported the two files, the everything or all.sql and the schemas.sql, and let's look at them to verify what they are. Open it in my editor, and we have the all, and we have these schemas. So let's look at the all real quick, and we can take that out. So as you see, when it exports, it already puts it in a transaction for you, which is very useful. And we see that we have our pet owners table, we have our pets table, we have our people table, and then we have the information going in. Which I'm really confused by the order. But okay, if this works, it works. I'm confused by the order, just to be clear, because this is the first table here, even though it references these two different tables that may not exist. So hopefully if it works, if it doesn't work, then we can just rearrange the order, move these two to the top and move this line to the bottom. But we can actually verify if it works. Let's do that first. To verify if it works, we can copy and paste this entire thing. Create a new in-memory database. Cancel, don't create any tables. And in the SQL box, just drop it in and execute. And we want to run all. And as we see, the tables didn't work. So this is not a foolproof plan, and I was right in my assumption. So let's move some of this around. Move that up here. Move this up here. Move this down here. And I guess we don't really need all these extra spaces. Copy, and let's try this stuff. And that worked fine. So we did have to rearrange the code a little bit, but being able to export SQL and not have to write all of it ourselves, it's kind of nice. And let's look at our schemas, which has the same thing. We can just move these two above this one. And we can verify that this one works too by doing the same thing. Open a new in-memory database. Do not create any tables. Paste it here and then run all. And that looked like it worked. And we have our tables here and we can verify. All right, so once you have reached this point, we have our schema that we're going to use for our database. We know that we can use the SQL code to create our database. And thus, I believe that we're ready to start writing code and interacting with it via Rust. All right, so that's the end of this video. The next video is going to continue onward with this trend, and we're going to actually start writing some Rust code. Deuces. Peace.